Now let's talk about how the S of n of an arithmetic progression was derived. That is, the formula to calculate the sum of an AP, how the formula is gotten. Hopefully at the end of this video, you will understand the basic idea behind it. So let's begin. Let's consider an AP to be a sequence of, let's say, odd numbers: 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Let's stop here. Okay. Now, if I just want to find the sum of number of terms in this particular sequence, what I will do is that I'm just going to sum the number of terms together. Okay. That's 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17, and lastly plus 19. Perfect. Now let me try to use my calculator to confirm this. So we have 1 plus 5 plus 3 plus 7 plus 11 plus 19 plus 13 plus 15 plus 17, and so on. So in the end I have 100. So S of n is indeed equals to 100. But it turns out that this result can also be gotten in another way around. So what exactly it is? Let me assume the sum in the first case. Let me say S sub f is equals to 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Okay, perfect. Now, what I would like to do in this case is that I want to flip the order at which the number of terms are occurring. I want to start now from the last value, that is the last number of terms, all the way to the first number of terms. So S sub second, okay, that will now be in the other way around. Okay, that will be 19 plus 17 plus 15 plus 13 plus what next? That's 11 plus 9 plus 7 plus 5 plus 3 plus 1. Now at this point, I would like to add both equations together, like both sides. I will add both sides respectively. I want to check if my answer is at all going to be the same thing. Hopefully you're following. Alright, I would like to create some little more space. Okay. Alright, fine. Now I would like to add both expressions together in some days. So I'm going to have 2s, okay, sub f s. That one's actually relevant. It's just for you guys to be able to identify how I actually arrange the number of terms. Okay, so I'll just put 2s alone. Perfect. This will now be equals to adding each number of terms respectively accordingly. So the first one is 1 plus 19, so that should be 20. Okay, so I should have 20 plus 3 plus 17, that should also be 20, plus 5 plus 15, that should also be 20. So it turns out that everything will be 20, 20. So 20 plus 20 plus 20 plus 20 plus 20 plus 20. Alright, let me count the number of terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the output is 10, 2, 4, 6, 8, 9, 11, 1 more plus 20. Perfect. So the next thing I would like to do is just to add all those 20s together. So 20 in 10 places, that should be 200. So 2s is now equals to 200. And at this point, I would like to divide 3 by 2. And doing this, I should have s to be indeed equals to 100, which actually corresponds to this. And therefore, we can add number of terms in this way as well. Now, it is this idea we will be using to get the formula that helps us to calculate the sum of an AP. Now, let's consider the general term of an AP. We know that it's of this form: A, then followed by the addition of the common difference. Okay, and respectively, the common difference will keep on increasing as the number of terms increases. Okay, and A plus 4D, comma, and A plus 4D, and this will keep on increasing like that, all the way to A plus N minus 1 D. Perfect. Now, what if we want to solve these terms together? What will we do? We know that it's going to be of this form: S of n to be equals to the addition of each term, A plus D, then it keeps on adding this all the way to A plus n minus 2D, n plus, alright, then A plus n minus 1 D. Perfect. Now, concerning the basic concept we used earlier for numbers, let's apply the same thing to variables as well. I would like to flip the order at which these terms tends to occur. So I would like to have another sum, S sub, let me say T, to be equals to A plus n minus 1D, then plus A plus n minus 2D, n minus 2D, and this will keep on increasing or decreasing rather, because this is at which is in a descending order. So this will descend all the way to A plus D. Then lastly, it will end with the first term, which is A. Perfect. Now, having gotten this, I would like to add these two terms together, these two equations together. So adding this up, I should have 2s sub n t. But since the sub are irrelevant, I don't really need them. It's just to justify those values. Then I would like to add these terms respectively. So let me begin by adding this A and this together. If I add that up, I should end up having 2A plus n minus 1 D. So if you are wondering how it turns out to be that, let me try to justify it. Okay, perfect. So if I have A plus n minus 1D, then I can add this up since they are like terms, and I should have 2A plus n minus 1D, and that is how the result is gotten. Perfect. Now the next term is A plus D and A plus n minus 2D. So what will that become? So let's see. If I have A plus D and I want to add it to A plus n minus 2D. Excuse me. Alright. Let me try to distribute this D for everything I have within it. So I should have A plus D plus A plus ND minus 2D. And it turns out that I have some like terms currently. So I can add them up. I have 2A. Now I have plus D minus 2D. That should be minus 1D. Minus D. Then I have this left over. That's ND. Then ND. Okay, plus ND. Plus ND. Now since D is common here, I can just take D as a common GCF. I have 2A plus n minus 1D. And therefore, we're going to be left over with plus 2A, then plus in the bracket of n minus 1D. Perfect. Now, this will keep on increasing, or it keeps on being something similar to 2A plus n minus 1D. Since we don't really know what is over here and here, So let's just put dot dot dot, showing that we have some values there. And the next thing I would like to do is to add a plus d and a plus in the value of n minus 1d, n minus 2d. But it turns out that is what we did over here. So therefore, our answer should be the same thing as this. So it should still be 2a plus n minus 1d. And the last one is this and this. But it turns out that they also correspond to the addition of this and this, and therefore we should have the same result as this. So in the end, our answer should still be plus 2a then plus n minus 1d. So what do you observe in the pattern? What do you notice? And notice that this value keeps on being the same thing. It's just that it keeps on repeating depending on the number of times you're having. So we can make a general conclusion that 2a or 2s rather, excuse me, that 2s is now equals to 2a plus n minus 1d and everything multiplied by n. This way helps us to know the amount of the sum that we are going to be adding in. Once you multiply by n, you have the exact number of terms. You understand? That's how that works. So if I divide 2 by 2, I should have s to be equals to n by 2 in the bracket of 2a plus n minus 1d. And this is the general formula to calculate the sum of an arithmetic progression. Okay, if you are wondering or if you are very curious about how this n comes here, okay, the purpose was because over here we'll observe that all the value we are having to the left or to the right are all 2a plus n minus 1d. Now, you know, in a particular problem, you can't have infinite series. You can have it, but it depends. You know, if you don't have infinite series, or if you have infinite series, they will actually find the sum of a particular number of times. You can't have you actually find the sum of infinity. That is in geometric progression. That when you can find the sum to infinity. Okay, but for an arithmetic progression, you can't find the sum to infinity. You will find it to some finite number. So to know the exact finite number, you need to multiply this by n. And that is how the n comes around. Okay, so hopefully you now know where the formula to calculate the sum to infinity of an arithmetic progression comes from. If you haven't subscribed to my channel, please do what to subscribe. Now let's try to apply this formula into a problem and see the beauty behind it. So here is a certain arithmetic series. So let's assume we are to find the sum of the first 8 term of this series. Now you can see that we don't have up to the 8th term. We will rather have the first term and the second term. So there's no way we can just add those terms together to get the sum. So for a problem like this, the best thing to use is to use the formula we just derived. Okay, so therefore s of n we said is equals to n by 2 and multiply by 2a plus then n minus 1 and multiply by d. So your main goal is to identify 3 different quantities, which is a, d, and n, whereby a is the first term, d is the common difference, and n is the number of terms respectively. Fortunately enough, the number of terms is given to you as 8, that is the sum of the first 8 term. Now what will be the first term? Whatever value begins the sequence of series, assuming or just know that it is the first term. That's 1. So what about the common difference? Since it is an AP, to get the common difference, you have to subtract the first term from the second term, or the second term from the third term, or the third term from the fourth term. That's all. Okay, so therefore d will be equals to 5 minus 1, which is 4. And boom, just substitute. Then you have, the sum of the 8th term. So s of n will be indeed 8 by 2 Then 2a, or 2 times 1 plus 8 minus 1 multiplied by 4. So I have 4 multiplied by 2 plus 7 times 4. 7 times 4 is 28. 4 multiplied by 2 plus 28. So that's 4 multiplied by, okay, let me try to make it perfect. Also then equals to 4 multiplied by 30. So 30 by 2 is 60. So I have 120. So S of them is 120. And this is the beauty behind this formula. Thanks for watching. I really appreciate it. So see you guys in the next video.